So in this last look at solid solutions, we're going to take advantage of this very nice diagram from the online mineralogy textbook of Dexter Perkins, where he shows defects. But these kinds of defects that he's showing here, the Schottky, the Frenkel, etc., they also relate to types of solid solutions. So let's illustrate how. So if we had a perfect crystal, and where or when would we find a perfect crystal? Well, a perfect crystal, we'll just write XTL for crystal, would be one that exists at 0 Kelvin. So in theory, at a temperature of 0 kelvins, we would have crystals that would be perfectly lined up. Now, it's not going to be anywhere close to perfect when I draw it, and this is always really quite bad. I don't really mean to have bumps and ridges, but if these were all equally spaced and equally sized, then we would have a perfect crystal. Well, here in this diagram, you can see sort of ridges and valleys and bumps and vacancies, and this crystal is highly imperfect. And that is exactly what we would expect for any crystal that exists at a temperature greater than 0 kelvins. So let's take a look at the kinds of defects that occur. We'll start out with this set of 4 here. That can be our reference. So here with those 4 atoms in 2 dimensions, there is a opening right there in the center of those. And let's say we were to jam an atom inside that site. Well, that's the case here for an interstitial atom that is being jammed into that site. It forces all those 4 atoms apart from one another. It's called an interstitial defect. It's also an type of solid solution called an interstitial solid solution. So we can just write that here. So an interstitial solid solution is when you jam an atom into a site where it normally doesn't go, given the regular stoichiometry of a given mineral. Then we have sort of simple substitutions that we looked at before. So we have a video on substitutional solid solution. So substitutional, we'll make sure to spell that right. And that's simply when we take, let's say, a 2+ cation and substitute another 2+ cation. And they go into the same site, but maybe one's a little bit larger or smaller. So here's our little group of 4. Here's a substitution where the substituting atom is a little bit smaller. Here is the same group of 4 here, but we've put in something that's a little bit larger. So we have an impurity defect in both cases, one where the atom is large and one where the atom is small. If you look back at our video on substitutional solid solutions, it's basically the same idea. Then we have the case of a vacancy defect, where we just pull an atom out. So that's also called a Schottky defect, and that also relates to another kind of solid solution. Let's say that this atom here is normally a 1+. So over here, well, let's draw a little arrow. Let's say that's usually a 1+ cation. Let's say the guy who sits over here is also a 1+ cation. So together they add up to 2+. And let's say this guy is also a 1+. Well, if we want to substitute a 1+ cation with a 2+ cation, maybe we want to substitute potassium with lead. They're very close to the same size, but the charges are different. So lead can fit, but it's got the wrong charge. Well, what can happen if you want to put a lead atom over here instead of a potassium? Well, you could pull out one of the potassiums and leave that vacancy to maintain charge balance. So that vacancy would lead to something we refer to as omission solid solution. So omission solid solution is the case when we substitute an atom that has too large of a charge, and we make up for it by simply pulling something out of the structure. And by doing so, we would also create a vacancy defect. And then the final example shown here, here's our group of 4, a little bit distorted, is when we create a vacancy by putting something into an interstitial site. So it's kind of a combination of this case here plus this case over here. So we're going to create a vacancy, and we're going to shove that atom into a place where it normally wouldn't go. We'll put it on that interstitial site. It'd be in between those 4 atoms there. In this case, that's not really related to any type of solid solution, but it just allows us to kill 2 birds with 1 stone. We're looking at a set of defects, in this case a displacement or a Frenkel defect that is not necessarily related to any kind of substitution or a solid solution that we've been speaking about in the other related videos, but they're really kind of part and parcel of the theme, all except for this guy. All of these types of impurities and vacancies and interstitial defects are also types of solutions that we refer to as omission or substitutional or interstitial solid solution mechanisms.